Towering 85 meters above the Norwegian countryside, Mjøstårnet cuts a sleek shape in the rural skyline. Housing 18 stories of restaurants, apartments, and hotel rooms, this modern building might seem out of place, but a deeper look reveals it actually blends in quite well among the forested farmlands. This is likely because Mjøstårnet is the world's tallest wooden building, made almost entirely from the trees of neighboring forests. Until the end of the 20th century, engineers thought it was impossible to build a wooden building over 6 stories tall. Traditional boards of lumber were fairly strong against forces parallel to the wood's fiber growth, but they were vulnerable to forces applied perpendicular to this direction. As a result, wood lacked steel's tensile strength, or concrete's compressive strength, each necessary to support tall buildings and battle the powerful winds found at high altitudes. But the early 1890s saw the invention of glue-laminated timber, or glulam, and a century later, engineers developed cross-laminated timber, or CLT. These new wooden materials start out like all other lumber. A freshly cut log is sawed into smooth, uniform boards of wood. Then, in the case of CLT, the boards are glued together in alternating orientations, with each layer set at 90 degrees to its neighbors. The resulting material benefits from wood's structural rigidity in every direction, allowing it to mimic the compressive strength of concrete and bear loads up to 20 times heavier than traditional lumber. Glulam, on the other hand, glues boards together in the same direction, forming massive beams with tensile strength comparable to steel. Glulam isn't as versatile as CLT, but its incredible strength along one direction makes it superior for load-bearing beams and columns. These engineered forms of wood could finally compete with traditional materials, while also bringing their own unique set of advantages. At 1/5 the weight of concrete, building with CLT requires smaller cranes, smaller foundations, and fewer construction workers. While concrete has to undergo a time-intensive process of casting and curing in a mold, timber can be shaped quickly using computer-directed cutting machines. And where concrete requires certain weather and timing conditions to be poured on site, engineered wood can be prefabricated in a factory, creating standardized parts with clear instructions for assembly. Taken together, these materials allow for faster and quieter construction, with more biodegradable materials and less waste. Once constructed, CLT and glulam buildings are also more resilient to some natural disasters. An earthquake can crack concrete, permanently weakening an entire structure, but cracked wood panels can be easily replaced. The same is true for fire safety. As temperatures rise in a CLT building, the material's outer layer will char, insulating the inner layers for up to 3 hours. This is more than enough time to evacuate most buildings, and once the smoke is settled, charred panels can be swapped out, unlike melted steel beams. But perhaps the biggest benefits of CLT and glulam are outside the construction site. Building construction is responsible for 11% of annual global carbon emissions, and the production of steel, concrete, iron, and glass are major contributors to that figure. Timber, however, is a renewable resource that can be made carbon neutral if trees are planted to replace those cut down. Wood also has low thermal conductivity, making it easier to heat and cool buildings with less energy waste. Despite these advantages, CLT requires vastly more lumber than traditional wooden construction, and when compared in similar quantities, neither CLT or glulam is as strong as steel or concrete. Even Mjøstårnet isn't made entirely of wood, as it contains concrete slabs to reinforce the upper floors. Taken together, it's unlikely that a purely wooden structure would be strong enough to support a 40-story building, the minimum height for a formal skyscraper. But even if only buildings under 30 stories were built from wood, it would reduce the carbon footprint of those structures by more than 25%. So no matter how tall these wooden buildings rise, each one contributes to the health of our concrete jungles.